Greetings from Colorado, where the skies are still dark at night and you can see the Milky Way. This is During the Night Sky with Zachary Singer. There's a lot to see in the constellation Virgo. Even if you don't have a telescope, Virgo's deep space objects are worth hearing about because some of them can blow your mind. We've got a cool double star, an even better galaxy, and then, well, something rather grander. You're getting a taste of it right now. We'll take a good look at these in just a few, but first, let's get oriented. Virgo's outline, as you see here, is supposed to represent the young maiden of spring, since that's the season for her evening appearance. Quite frankly, a young woman's form probably doesn't seem obvious here, and the traditional illustrations of this constellation aren't much help. So we're going to take an informal approach, and I think you'll find it much easier. Our way, we'll imagine Virgo reclining on a couch, like she's posing for an impressionist painter. We'll start with the bright star Spica, brightest in the constellation. You'll find that Spica will be an important reference, which we'll talk about shortly. If it helps, you can imagine it as a bright diamond on her hip, or a really hip star. Here's her other hip, here are her shoulders, and here's the curve of her waistline. This last star is easy to miss, but once you know to look for it, Virgo will become more recognizable. Now, here's her left leg, bent artistically at the knee, and her right leg similarly bent. The matching shapes will help you recognize this part of the constellation. Finally, here's her left arm outstretched on that couch, and her bent right arm with her elbow here. Perhaps she has her hand behind her head. So there you have it, a modern Virgo with a simple, solid outline. Renoir and Matisse would be proud. As for how to find this constellation, look for Spica first. That's not hard in mid-May. Just look for the southern horizon around 10 p.m. and then move your eyes about halfway up the sky until you find our bright, cool white star. If it's earlier in the month, shift your gaze a little to the east, and if it's later in the month, shift west a bit. The same goes for looking later on any given evening. Every hour, the star moves westward a little more than the width of an outstretched hand. Here's a really great trick though. Around 10 p.m. is in our first approach. Point your toes southward and start looking upwards. Keep going until you're looking at the sky directly overhead. You'll see the Big Dipper looming over you. Follow the curve of the dipper's handle away from the bowl and you'll quickly notice a bright yellowish star. It's about the same distance from the end of the handle as the size of the dipper itself. This star is Arcturus, an important landmark for navigating this part of the sky. If you keep following the curve you were on for about the same distance, you should quickly find Spica. It's the only bright star in this direction after leaving Arcturus. Once you get used to this Dipper to Arcturus to Spica trick, you can use it any time these stars are visible, not just at our specific reference time. Just remember the Dipper will rotate as the hours and the days pass, so you may need to look for it at different angles. Let me quickly mention that our sky is optimized for 40 degrees north latitude: Reno, Denver, Philadelphia, Paris, Beijing. If you live north of 40 degrees, Virgo will be lower in the southern sky. If you live south of 40 degrees, you'll see Virgo higher up. That's it for getting oriented and finding this constellation. Let's have a look at the good stuff now. Our first stop is Porrima, also known as Gamma Virginis. We just saw this star when looking at Virgo's outline, but it's not just a good landmark for recognizing Virgo, it's also a fascinating binary star. Binaries are pairs of stars that actually orbit each other. What makes Porrima unique is that for part of its orbit, you can witness the stars passing each other over the span of just a few years. The two stars get closest to each other about every 140 years or so. They fly fastest in their orbits during this close approach, so the positions of the stars shift noticeably year to year. This last happened in 2007. Here in the spring of 2020, the two stars are already noticeably farther apart. Don't worry, they're still close enough to each other to need relatively high power to separate or split them. Keep observing Porrima over these coming years though, and you'll notice that you need less and less magnification, because the distance between them keeps widening. Before their orbits begin to narrow again, decades from now, the two stars will be twice as far apart as they are currently. If waiting years to see a change isn't for you, Porrima is also a beautiful pair of matched pearls in your telescope, and being as tightly spaced as they still are, they make a good challenge for beginning observers. Next up, a wow target in any year, Messier 104, the Sombrero Galaxy. You can just call it M104 though, for short. This striking galaxy is a spiral like our own Milky Way, but about 1/3 larger. The sombrero's trademark silhouette comes from the nearly edge-on angle we're viewing it with. To give you some perspective, if this galaxy were a giant pizza, we'd have an excellent view of the edge of the crust and a lousy view of the pepperoni. So, in place of a pizza crust, we get to see the galaxy's dark lane, and it's quite a view. You can easily see M104's central dark lane in a 10-inch telescope under a dark sky, and the galaxy's shape overall with an 8-inch. Even some decent binoculars, though, are likely to at least pick up M104's glow. When you look at this galaxy, remember that the light you see is a product of more than 100 billion stars, and that the light now striking your eyes left those stars nearly 30 million years ago, long before mankind or our ancestors even existed. You'll find M104 here, just above this dim little star, almost on a perfect line back to Porrima. If we delve deeper into the details of M104, it would get more and more amazing, and yet there is something of such immensity that even the huge, magnificent M104 begins to look small. This is the Virgo Cluster of Galaxies. You'll find it roughly here, nestled between the star Denebola in Leo, which we saw last month, and the star Vinda Beatrix, this bright one in Virgo. Instead of one galaxy, like we just saw with M104, there are over 1,000 galaxies in the Virgo cluster. Here are some that are bright enough to be seen with a moderate 6-inch telescope. And here are some of the dimmer ones. They'll be visible in a 12-inch scope. These galaxies lie roughly at distances of between 40 and 60 million light-years from us, or about twice as far away as M104. So look dimmer in a telescope, but there sure are a lot of them. Let's come in a little closer and have a better look. Now, here's what's really out there. Finally, here's the Markarian Chain, just a sample of what's in the cluster. I've seen this myself in my 12-inch scope, and the view is unforgettable. Some of you may have telescopes too. If your view isn't wide enough to take in the whole chain at once, you can sweep your scope through this area. But even if you don't have a telescope at all, that doesn't change the fact that these objects, these many trillions of stars, are still out there, high in the sky as you look south on a May evening. We are bound to it all by gravity. Our last idea for the moment is that the Virgo cluster is not the biggest, or the grandest, or the farthest structure in our universe. Not at all. It just happens to be the closest cluster, and actually just an average one. There are far more of these throughout our universe, and they bind themselves into even larger and more unimaginable groupings. If nothing else, remember this when your boss gives you a hard time. Clear skies, my friends.